Here, it is a chemical change in which one or more substances are destroyed and one or more new substances are created. This we call it as a chemical reaction. When you see here, hydrogen gas is reacting with your oxygen gas, right? In this particular reaction is what it is happening is a bond between your two hydrogen atoms is breaking and bond between two oxygen atoms is breaking, and finally you're getting a new molecule where you got a bond formation between oxygen and hydrogen combinedly. Okay, in the before part we have only a bond between the two hydrogen atoms and bond between two oxygen atoms. Now whenever it underwent a chemical reaction, you got a new molecule where you have a bond between both the atoms, that is your oxygen and hydrogens here, right? This is called as a chemical reaction. Now when you go with the parts of your chemical reactions, actually this will come under your chemical equation. I don't want to go with this part. I'll just go on to your chemical reaction here. Next, we have some evidences. We need some evidences for the chemical reactions to take place. Generally, we have some chemical evidences which can be visible, which can be felt, so that the chemical reaction is taking place. The first and the foremost process is your evolution of your light or heat. Okay, whenever your light energy is there, okay,
enthalpy change,
it will release your heat there.
Yes, ma'am.
Okay, this release of heat is an indication of your chemical reaction, and in some reactions there is also a release of light. That is also an evidence for a chemical reaction. Okay, so this is first thing here. Next thing,
can you give me an example for evolution of light?
Yeah, see here, you can see that, a simple thing I can go with here is, whenever you're turning on your light, just you think you have a bulb is there.
Yes, ma'am.
Before turning on the bulb, when you touch the bulb, you feel cold. Okay, right? When you turn on your light, what happens there?
Ma'am, the bulb begins to heat up.
The bulb will glow first, and if you keep that for some time, if you keep the bulb glowing for some time, it will become heat there. Means whatever the electrical energy is there, that electrical energy is converting into your light energy, and light energy is converting into your heat energy there, right? Okay. So this is an evidence for the chemical reaction. How can we say that it is a chemical reaction? Means inside the bulb you will be having a metal tungsten filament, right?
Yes, ma'am.
Metal tungsten filament is undergoing reaction with your electrical current. It is burning there, right? So that will releases your light, convert, means the electrical energy is converting into your light energy, and simultaneously your heat energy is released there. These are all the evidences for your chemical reaction. That is the first evidence. Next, another evidence here we have temperature change. You can see here we have a temperature change. That is either your increase or decrease in your temperatures of your surroundings. That is also an indication for your chemical reaction. For example, you take your, I'll just go with a sodium hydroxide pellets. You know what is the sodium hydroxide?
Yes, ma'am.
Sodium, what is the nature of sodium hydroxide?
Ma'am, basic.
It is basic in nature.
Basic
Take
nature.
sodium, take sodium hydroxide. Try to dissolve your sodium hydroxide in water. What happens is, so soon you will get your sodium hydroxide diluted. Okay, the pellets, the solid substance, you're getting converted into a solution there. Here, during the preparation of your sodium hydroxide solution, what happens is very high amount of heat energy will be released there. If you're not cooling your beaker simultaneously while adding your water to your sodium hydroxide, the beaker will break there. That much high amount of heat energy will be released there. Right?
Yes, ma'am.
Okay. Here what happens is, whenever the heat energy, this indication that the high amount of heat energy is released, no, it is an indication that the reaction here is exothermic reaction. The reaction between your sodium hydroxide and water is highly exothermic. If I want to go with a normal example, like you take your glass of water, to this glass of water, you add your glucose solution. Glucose, you just add glucose. Stir it. After dissolving your glucose in water, if you touch the glass, what will you feel?
Ma'am, I haven't practically done this, so I don't know.
Yeah, if you do it practically at your home, after dissolving your glucose in water, if you touch the glass, you will feel very cold. Okay. Here, there is a decrease in the temperature of your solution. This indicates that it is an endothermic reaction. Right?
Yes.
So these are all the heat energy release, heat energy absorbing. All these are the evidences for the chemical reactions. Right? Can you see the screen here, ma?
Yes, ma'am.
So these are the this is another evidence we have. Next, second evidence, the third evidence we have here is.
Your voice before.
Am I clear now? Am I clear now?
Yes, ma'am. Yes. Yeah. Maybe my site's net problem.
Okay. So another evidence here we have here is the formation of your bubbles, gas bubbles. Okay. Can you give a general example which you come in your everyday life where there is a release of gas?
Ma'am, when we add zinc granules in hydrochloric acid or sulfuric acid.
Okay, well, this is a chemical reaction you're doing. Take zinc granules, add it to hydrochloric acid, it will get converted into a zinc chloride and hydrogen gas. The evolution of the hydrogen gas will be in the form of a vapor. And if you put these gases in your soap solution, it will bubble there, right? The bubbling indicates that it is a gas producer there. This is an activity what you will be doing in your school. Now, when coming to the normal reaction, when you open your, Coke tins, you just shake your Coke tin vigorously and just open it up. What will happen there?
Ma'am, I don't understand. Please repeat this one.
You just take a soft drink. Soft drinks are there, na?
Yes, ma'am.
You just shake the soft drinks vigorously and just at once open the lid. What will happen there?
Gas evolves. Gas evolves.
Gas evolves. What is the gas evolved there?
I think, ma'am, carbon dioxide maybe.
It is your carbon dioxide gas. The bubbling of your carbon dioxide gas, the evolution of your carbon dioxide gas in the formation of bubbles will come out from the soft drink. Because soft drinks are nothing but these are your carbonated waters. These are your carbonated water which will contain carbonic acid H2CO3. Okay.
Okay.
So these are the general things. which is an evidence for your chemical reaction. Next, we have your another example here. Another evidence you can see here, the change in color. The change in color is also an evidence for the chemical reaction here. First and the foremost thing here is rusting of your iron. Here you can see that when you take a brand new iron nail, it will be shining, right?
Yes, ma'am.
If you keep it in an open place or put it in water for some time, you can see that the color will change. It will get converted into your red, brownish color, reddish dark color you will be getting. This is due to the rust formation. Iron is getting oxidized with oxygen and it will get converted into your iron oxide. This is nothing but your rust there.
But rust formula is Fe2O3.X2, ma'am. What
Yes,
is
yes.
that option X?
FeO, Fe2O3, all these are the rust only. If it is your FeO, it is your iron 2 oxide. It is your iron 2 oxide. Fe3 or Fe2O3 means it is your iron 3 oxide.
Ferric oxide.
Okay, ferric oxide and ferrous oxide.
Yes.
So these are the two things what you will be having. So this is the part here, and last evidence here is formation of a precipitate. We have some chemical reactions which will be accompanied by the formation of a precipitate here, right? For example, you take a solution. See here, you can see that some yellow precipitate has formed. Initially, both are liquids only. Whenever they got reacted with one another, you get an insoluble precipitate. This insoluble precipitate is an indication for the chemical reaction has taken place.
From this PbI2.
PbI2, lead iodide. Yes, yeah. Lead iodide is your yellow precipitate. Okay. So these are the general evidences for the chemical reactions which has taken place. Next. So these are the reactions, evidences for the reactions here. Next, we have the other part here, types of chemical reactions. We have basically 5 different types of chemical reactions. That is your first reaction here is your displacement reaction. This displacement reaction is generally divided into 2 types. One is your single displacement reaction and another one is your double displacement reaction. After that, we have your synthesis reaction. The other name for synthesis reaction is the combination reaction. Next is decomposition reaction. Another one is combustion reaction. And last reaction we have is the redox reaction. These are the 5 different types of chemical reactions you will be having. Displacement reactions, when we go with the displacement reaction here, whenever one element takes the place of another element, that we call it as a displacement reaction. Simply normal, the name itself indicates displacing. One element is displacing the other element. That we call it as displacement reaction. For example, when you see your single displacement reactions, in this single displacement reactions, what happens is only the elements in their free state, that is your pure metals, okay, only elements in their free state, that is also your metals, will undergo your single displacement reactions. For example, you take your zinc, make it react with your copper sulfate. Right, Abhinav? Are you getting the point here, ma? Soon it will get converted into your zinc sulfate and copper. Abhinav, am I audible to you?
Yes, ma'am. Yes, ma'am. I'm listening.
Yeah, okay. So here you can see that I have taken a metal zinc here in its free state, made it reacted with your copper sulfate. Soon it got converted into your zinc sulfate and copper. Means here zinc has taken the place of copper by kicking out copper, right? Now, another thing you see, I take copper, make it react with your zinc sulfate.
Hello.
Yes, Abhinav.
Yes, ma'am.
I took metal zinc here, copper,
Hmm.
made it react with zinc sulfate. Now I am asking what will be the product here.
Ma'am, there will not be any chemical reaction, so therefore there will not be any product.
Yes, here no chemical reaction will take place. So there is no product here. Now, why there is no chemical reaction is taking?
Ma'am, copper is placed below in the reactive series, then zinc is placed above.
So
Zinc is
whenever
always.
you're carrying out your displacement reactions, the metal can displaces the another metal only if its reactivity is higher than the another metal. Here, zinc has the capability to replace your copper because zinc is highly reactive than copper. It is placed above the reactivity series. Copper is placed below the reactivity series. So copper cannot replace your zinc. So there is no reaction between your copper and zinc sulfate. Only there will be a reaction between your zinc and copper sulfate. Right? This type of chemical reaction, we call it as, right?
Yes, ma'am.
After seeing here, this is the thing here now. The same thing here, what we have discussed here. Copper sulfate solution will be blue in color. When you put zinc here, it will become colorless there. Getting a red displacement reactions. These are the other examples what we have for your single displacement. Next, we have the double displacement reactions. When coming to your double displacement reactions, here, when two elements will get replaced one another simultaneously, then such type of reaction, we call it as double displacement reaction. In this example, you can see AgNO3, make it react with your sodium chloride. This is one compound and this is another compound. Soon you will be getting your AgCl and NaNO3, sodium nitrate. Sodium has taken the place of silver. Silver has taken the place of sodium. Two metals has displaced their places. Such a type of reaction, we call it as double displacement reactions. Right?
Ma'am, why do they exchange their ions, ma'am? Why
Yes,
do
ma'am.
they?
Why do?
Ma'am, why do they do so, ma'am? As sodium is making ions with the nitrate ion bonds with nitrate ions, and silver is making ions making bonds with chlorine. Ma'am, why does this happen, ma'am?
Why does this happen? Means you can see the dissociation here. Aqueous solution you take. Sodium chloride is generally it is an aqua. It will be in your aqueous solution. Even the AgNO3 in your aqueous solution. It will be your Ag plus and NO3 minus. Sodium will be your Na plus and Cl minus. Now the opposite charges will react with one another like this.
No, ma'am, I'm not asking this. What I'm asking is, ma'am, that why do they, ma'am, in this particular chemical reaction, why do the sodium will attract NO3 and not Cl? Why is not satisfied with chlorine?
You're asking why sodium is the positive part here, right? And
Yes,
chlorine is the negative part here. It is a
Hmm.
cation here, it is the anion here. And in this part, it is the cation here, it is this nitrate ion is the anion here. Whenever two different ionic compounds are reacting with one another, again the cation and anion only will react now. And moreover, sodium is a metal, silver is a metal, and even sodium is also a metal. It is an alkali metal and it is a transition element here. Okay. Here what happens? Both are electropositives only. Two positive parts, they cannot form bond. Na?
Yes,
Right?
Yes.
This is the part. Always there will be, whenever you're taking your ionic compounds, always there will be a bond between your metal and a non-metal only. Metal and non-metals only will form an ionic compound there. the part. So this type of reaction, we call it as a double displacement reactions. And these double displacement reactions, some of the double displacement reactions are accompanied by the precipitate formation, gas ebullition, and water formation. Okay. Whenever a double displacement reaction is happening, you will be having your precipitate formation. See here, AgCl and sodium nitrate, both are soluble in water. If you take your AgNO3, it is another type of chloride and nitrate, sulfates, all these are water soluble ions there. Okay, just like you told your lead iodide formation, barium sulfate, barium chloride formation, barium nitrate formation, all these will be precipitate reactions you will be having. So generally, whenever your double displacement reaction will take place, there you can find a precipitate formation, or gas is produced, or sometimes you will be having a water formation also. Right? See, this is the part. Take your lead nitrate.
Gas evolution.
Yes, yes.
Gas evolution and water formation would be done when the reaction would be neutralization, no?
Yes. Generally, it is between your salt and acid and base. This is the form here you can see. Calcium carbonate, yes, which is a base, making it react with your acid. Soon it will get converted into your calcium chloride and water and carbon dioxide gas. Yes. This is the general reaction. Actually, this carbonic acid you will not show. Whenever you show the reaction between your calcium carbonate and HCl, the complete reaction how you will be writing is calcium carbonate reacting with your HCl. It will form your calcium chloride, water, and carbon dioxide, gas evolution and water formation. These two will combine to form a new gas, that is a carbonic acid. Okay?
Yes, ma'am.
Yes. And between your acid and base, you will be having a neutralization reaction. It is also acid and base only, but it is not a strong base. It is a weak base and strong acid. And moreover, whenever you have your carbonate bases or carbonate salts, there is a formation of carbon dioxide in the product. Whenever you have a carbonate salt, always it leads to the formation of carbon dioxide.
Ma'am, it is also a condition for the displacement reaction that both the compounds should be in their aqueous form. But here, ma'am, calcium carbonate is solid. Hello.
Yes. What actually happens is there is no necessary that both the compounds should be in aqueous medium to take to have a chemical equation, that is a double displacement reaction to take place. There is no necessary that, because you see that calcium carbonate, the other name for calcium carbonate is, what is the other name of your calcium carbonate?
Limestone.
It is your limestone, which is nothing but we call it as a marble chips. Limestone is water insoluble compound. Okay, it is a base, but it is not soluble in water. So this you have to take it in your solid state only. And here you are taking your HCl in the aqueous state, right? Then only it will react with calcium carbonate. Here you are increasing the concentration of your water to get soluble in your carbonate. That is, you are making your water from neutral to acidic. Then only it is getting converted into your it is releasing your carbon dioxide gas. And formed calcium chloride is soluble in water, but calcium carbonate is not soluble in water. Okay?
Okay, ma'am.